The Lockheed P80 Shooting Star holds a remarkable list of firsts in American aviation. It was the United States' first true operational jet fighter, and its career was packed with milestones from the very beginning. It was the first American jet to see combat and score an air-to-air kill. On top of that, the P-80 was the first aircraft in aviation history to perform aerial refueling under real combat conditions. For a time, this fighter even held the absolute world speed record. Judged strictly as a combat aircraft, the Shooting Star proved to be far more successful and reliable than the world's very first operational jet fighter, the German Me-262. However, it wasn't the fighter itself that achieved the greatest global fame. Rather, it was the two-seat T-33 advanced trainer developed from it. It is rightfully considered one of the most successful trainers of the post-war era. The T-33 essentially gave the original fighter a second life. The combat variant of this trainer, known as the AT-33, turned out to be so successful that it is still in service with several air forces today. The United States entered the jet age relatively late, and that is not surprising since pioneering an entirely new field of technology was practically impossible without massive financial and organizational backing from the government. True jet propulsion enthusiasts, like German inventor Hans von Ohain and British engineer Frank Whittle, spent years working in obscurity before they finally earned official support and generous government contracts. The Germans took the lead in this race. Their Heinkel HE-178 aircraft, powered by Hans von Ohain's revolutionary HES-3 engine, made its historic first flight in late August 1939. Later, in the spring of 1941, the first turbojet fighter, the Heinkel He-280, took to the skies, and by the summer of 1942, the legendary Messerschmitt Me-262 made its first jet-powered flight. The British were not far behind. Their first experimental jet airplane from the Gloucester Aircraft Company was equipped with Frank Whittle's W-2B turbojet engine. It was successfully tested in May 1941, and in the spring of 1943, the British Gloucester Meteor fighter took to the air. It was powered by two Halford H-1 turbojets, generating around 1,500 pounds of thrust each. Meanwhile, across the Atlantic, top Lockheed engineers Clarence Kelly Johnson and Hall Hibbard had already begun their own in-depth research into jet aviation back in 1939. They drafted a whole series of ambitious concepts. As part of this, the company took the initiative to begin designing what was a truly unique aircraft for its time. This aircraft was designated the L-133. This bold project was built around a completely new engine developed by their colleague, engineer Nathan Price. His proposed L-1000 turbojet featured an axial compressor. It looked even more radical on the blueprints than the futuristic L-133 airplane itself. However, the United States Army Air Forces failed to see the potential in these overly advanced ideas. They showed almost no interest in the project and flat out refused to provide any funding for its further development. That situation changed dramatically when encouraging news started coming in from Great Britain about their successful progress with turbojet technology. An even bigger wake-up call came from American intelligence reports. These reports revealed that Germany and Italy were actively developing jet aircraft of their own. This forced the United States military leadership to take the prospect of building their own combat jets much more seriously. Even though the intelligence was fairly scarce, General Henry Hap Arnold instantly recognized its immense strategic value. As a result, the United States urgently put together a special committee on jet propulsion. It was headed by the brilliant engineer William Durand. The promise of heavy government funding instantly sparked the interest of industrial giants. Westinghouse quickly pitched their own turbojet design. General Electric brought forward a turboprop concept, and Alice Chalmers came up with a ducted fan variant. The U.S. Army and Navy split these promising concepts between them. General Electric was tasked with developing engines for the Army Air Forces. Meanwhile, the other two companies focused their efforts on the Navy. In April 1941, General Henry Arnold personally inspected the first British jet airplane. This was the Gloucester E-28. What he saw blew him away. It led him to one absolute conclusion. Something this important could not just be left to develop at its own pace. Just handing over technical specs was not going to cut it. American industry desperately needed hands-on expertise. And logically enough, they turned to their British allies to get it. Through what was known as reverse lend-lease, the British agreed to hand over the blueprints for their turbojet engines. This way, they could be manufactured locally in the United States. General Electric was selected to handle the licensed production. But choosing the airframe manufacturer to build the actual airplane turned out to be surprisingly simple. The military just went with the one located closest to the GE plants. That happened to be Bell Aircraft Corporation, since both companies were based in upstate New York. Work kicked into high gear, and on October 19, 1942, the first American jet took to the skies. This was the Bell XP-59A Aerocomet, powered by two General Electric IA engines. Although the XP-59A gave American engineers and pilots some crucial early experience with jet aviation, it was really more of an experimental aircraft than a true combat fighter. Mock dogfights pitting production P-59s against conventional piston-engine P-38 and P-47 fighters were a total letdown. The only advantage the new jet had over its older piston-powered counterparts was a tighter turn radius. Because of this, the U.S. Army Air Forces were forced to order the development of a completely new and far more capable jet fighter. Just 3 weeks after those revealing mock dogfights ended poorly for the jet, General Arnold made it official. The military would not be buying the Bell P-59A for combat missions. Instead, they decided to use it strictly as a trainer to transition pilots to the new technology. Meanwhile, as the fate of this aircraft was being sealed, tests for a brand new combat fighter were already moving full steam ahead in secret. Robert Gross, Lockheed's president, kept it simple when Clarence Kelly Johnson came to him with the idea. "Go ahead and shoot," he said. Those few words were all the green light Kelly Johnson needed to get to work. He was young, but easily one of the most brilliant and capable engineers at the company. He was put in charge of a small team of researchers, engineers, and mechanics. Their mission was wildly ambitious. They needed to cut through all the red tape and give the Army a true combat-ready jet fighter in just 150 days. Essentially, they had to accomplish what Bell had failed to do after several years of painstaking development. This sudden shift in America's jet program was once again driven by the success of their British allies. The British had just unveiled their new de Havilland Goblin turbojet engine. This was the most powerful in the world at the time. With alarming intelligence reports coming in about Germany's rapid progress in jet aviation, the conclusion was unavoidable. If they wanted to maintain air superiority, the new American aircraft had to be built around a powerhouse engine like the Goblin. Initially, developing a fighter around this new power plant was once again handed to Bell. They even pitched an upgraded version of their previous jet, the XP-59B. But at the time, Bell was completely swamped with other military contracts. Lockheed already had extensive experience with jet designs and experimental engines like the L-133 and L-1000. Because of this, Army Air Forces leadership made a bold move in March 1943. They decided to pull the single-engine fighter project from Bell and hand it over to Lockheed's engineering team. By May 1943, Lockheed engineers were officially briefed on the British H-1B Goblin turbojet engine. The long-term plan was to build this engine under license in the United States as the J-36. On May 17, 1943, a special conference was held. It was chaired by Brigadier General Franklin O. Carroll, head of the Army Air Forces Engineering Division. It was there that officials finally nailed down the preliminary requirements for the new aircraft. Lockheed was tasked with building a single fighter prototype. It was designed specifically around the H-1B engine acquired from the British. Wasting no time, Lockheed engineers began the preliminary design of their new jet. They gave it the internal company designation L-140. The team worked at a blistering pace. In less than a month, Clarence Kelly Johnson submitted the preliminary design for a fully capable combat fighter to Army brass. Impressed by the turnaround, the Army approved the L-140 project in just 2 days, on June 17, 1943. The contract was officially signed on June 24th. From that point on, the project was officially designated the XP80. The most demanding condition of the contract was the timeline. Lockheed committed to building and delivering the first completed airframe just 180 days after signing the deal. 180 days. There was absolutely no room for error. To meet this ambitious goal, Kelly Johnson teamed up with engineers William Ralston and Don Palmer. Together, they assembled a small but highly effective team of 23 engineers. The manufacturing floor consisted of 105 workers. It was led by shop foreman Art Vierek. Ward Beeman was put in charge of the aircraft's complex aerodynamics. Flight testing was overseen by Rudy Thorin. The work schedule was absolutely grueling. They worked 10-hour shifts, 6 days a week. This small group operated under a few simple but strict rules laid out by Kelly Johnson. Decision-making power and responsibility were completely centralized. Saving time was the ultimate priority. Once a design decision was made, it was final unless a change was absolutely necessary. Information flowed from engineering to the shop floor in the fastest, simplest way possible. Sometimes engineers literally explained blueprints using just hand gestures. Parts were procured specifically for this project. Materials were pulled from the warehouse without the usual bureaucratic red tape. In fact, the exact same people were receiving raw materials, fabricating the parts, assembling the aircraft, and conducting their own quality control. Designers were strictly limited to using readily available materials, even if it meant exceeding the aircraft's target weight. Of course, this streamlined organization looked flawless mostly on paper. In reality, the lack of bureaucracy sometimes led to some pretty comical situations. For instance, the team had to approve and immediately cancel a decision to install extra wing tanks twice. And it was all because the engineer designing the main fuselage tank simply forgot to clarify which exact gallons he was using in his calculations. He did not specify whether he meant the larger British Imperial gallons or standard US gallons. Because of this minor detail, management spent several days scratching their heads. They were trying to figure out if the aircraft would have enough fuel from just one tank. Guided by these principles, the team effectively locked themselves inside a purpose-built facility near the wind tunnel at the B-1 plant. There, under the strictest secrecy and in record time, they designed and built their first experimental XP80 fighter. The engineers went with a modern wing featuring a laminar flow airfoil. It had a low aspect ratio to reduce drag and improve aerodynamic performance. The aircraft featured a conventional tail assembly and a rugged tricycle landing gear. The heart of the fighter was a powerful British H-1B engine designed by Frank Halford. Its air intakes were cleverly tucked right at the wing roots. The exhaust was routed straight out the tail of the fuselage. The pilot sat in a pressurized cockpit. It was topped with a transparent bubble canopy for perfect visibility. As for armament, they tightly packed 550 caliber machine guns right in the nose of the aircraft. By late July 1943, a military inspection board reviewed a full-scale mock-up of the upcoming XP-80 fighter. The experts suggested 18 significant design changes. Right after that, assembly of the first actual prototype went into full swing on the shop floor. Since the project had top national priority, construction moved incredibly fast. To save precious time, they even decided to skip installing the complex pressurized cockpit on the first aircraft. Suddenly, though, a major issue arose with the turbojet engine. Their British partners could not deliver even a non-working test article on time. Because of this holdup, the engineers had to get creative. To avoid stalling the assembly of the aircraft, and to at least run the initial ground weight and balance checks, they temporarily dropped in a precise wooden mock-up in place of the real engine. The long-awaited first engine finally arrived well behind schedule. This was not until early November 1943. Even though this engine was only cleared for ground tests, they immediately mounted it in the XP80. After that, the completed aircraft was carefully trucked from Burbank out to Muroc Army Air Base. By mid-November, the United States Army Air Forces officially accepted the new experimental aircraft. From the moment the contract was signed to that milestone, only 143 days had passed. This was an absolutely incredible achievement for the aviation industry. Even while they were assembling the first XP80, the designers were simultaneously exploring backup options. They considered the idea of installing a slightly weaker engine from General Electric for the initial flights. This was the I-16 model. It was a licensed copy of the British W2B engine developed by Frank Whittle. The plan was that future production P-80 fighters would be powered by the much stronger H-1B engines. The Alice Chalmers plant was supposed to mass-produce these under license. However, engineering calculations quickly showed that the thrust from the I-16 engine just would not be enough for the heavy XP80 airframe. Because of this, they completely scrapped the idea. On top of that, development of another promising turbojet engine, the J-36, constantly ran into insurmountable roadblocks. They never actually managed to get it working properly in practice. Realizing this, in the fall of 1943, Lockheed pitched the military a concept for a significantly heavier jet fighter. This was under the company designation L-141. This fighter was designed around a massive General Electric ABR 40 engine. It was later produced by Allison under the J-33 designation. Army Command loved this revamped project. The military did not hesitate. They immediately ordered the construction of 2 improved prototypes, officially designated the XP80A. In mid-November 1943, Lockheed received a new turbojet engine called the Halford. During bench testing, this power plant, developed by de Havilland engineers, produced a maximum thrust of 3,002 pounds at 10,500 revolutions per minute. Meanwhile, its static thrust sat at 2,460 pounds at 9,500 revolutions per minute. On November 17th, they fired up the engine for the first time, installed in the experimental XP80 for ground runs. But the unexpected happened. The massive suction during startup completely collapsed both of the aircraft's intake ducts. The engine itself only suffered minor damage. However, the team decided to tear it down and inspect it anyway. And it is a good thing they did. They found a huge crack inside the compressor. Interestingly, this was not caused by the duct collapse. It was just a result of plain old metal fatigue. Naturally, running that engine any further was completely out of the question. While waiting for a replacement power plant, the engineers did not waste any time. They heavily reinforced the intake ducts. You could say this unfortunate ground mishap actually saved the aircraft from a mid-air disaster. After all, it later turned out that the exact same metal fatigue in the compressors caused as many as 9 serious failures during test stand runs. A brand new and fully functional engine was delivered on December 28th. They immediately installed it in the XP80. A few days later, right before New Year's Eve, it spooled up to full power without a hitch during a ground run. Finally, the aircraft was ready for its maiden flight. This historic event took place on January 8, 1944. That day, the XP80 took to the skies for the very first time, with experienced test pilot Milo Burcham at the controls. The entire team who built the aircraft gathered to watch the spectacle. They took 3 buses out to the surrounding hills just to get a good view. However, the flight had to be cut short after just 5 minutes. The pilot simply could not retract the landing gear. On top of that, it turned out the aircraft's ailerons were way too sensitive. But this did not deter the engineering team. They quickly tweaked the fighter right on the flight line, and Milo Burcham took it up again. This time, the flight lasted 20 minutes. During that window, the test pilot managed to check the climb rate. He also evaluated the aircraft's handling at the edges of the flight envelope. He executed a few aileron rolls and pulled off several steep climbs. Only during landing did another minor issue pop up. The flaps did not fully extend, but the overall impression was incredible. Eyewitnesses excitedly recalled that they had never seen such an insane roll rate before. The XP80 could snap through a full roll in just 1 second. After touching down, Milo Burcham enthusiastically reported that it was a completely new sensation of flying. During these initial tests, the aircraft hit speeds of 466 miles per hour. By January 15th, the aircraft had completed 5 successful flights. However, the celebration was premature. Subsequent tests revealed some serious flaws. The aircraft handled terribly in a spin, and it had a dangerously high stall speed. For example, when dropping the flaps, the fighter would snap into a sharp, uncommanded right-wing drop with 0 recovery time. On top of that, stick forces were excessively heavy. The fuel system was unstable, and the engine severely lacked reliability and thrust. The rudder behaved erratically too. Just to keep the aircraft flying straight, the pilot had to constantly work the rudder pedals back and forth, depending on the airspeed. Given all these issues, on January 17th, the engineering team took a 10-day pause to tweak the design. They started addressing the problems one by one. The sharp wing tips and horizontal stabilizer tips were swapped out for smoother, rounded ones. The wing root fairings got a sharper leading edge to improve airflow. Finally, the stabilizer's angle of incidence was increased by 1.5 degrees to improve handling. After all these modifications, the XP80 was handed over to the military's 412 Fighter Group for service trials. On February 12th, Captain Lyon took the aircraft up for a test flight. Even with the engine's power artificially capped at 75%, the XP80 became the first American aircraft to crack 500 miles per hour in level flight. By the end of March, the fighter's total flight time had reached 20 hours. In April, the live fire testing phase began. Over the course of 4 sorties, more than 1,200 rounds per gun were fired to test weapon reliability. The joint tests with the Army successfully wrapped up on April 13th. Right around this time, the British finished additional testing on their Goblin turbojet engine. The updated power plant was quickly delivered to the Lockheed factory. By May 26th, the aircraft was fully ready for new flights. However, just a few days later, on May 31st, an urgent warning arrived from England about the need to limit the engine's power output. It turned out that during test stand runs, several of these engines had suffered catastrophic failures at high power settings. Later on, the aircraft was sent back to Muroc Air Base. There, it faced a crucial evaluation, spin testing. The engineers needed to make sure that the wind tunnel data matched real-world flight characteristics. And as it turned out, their calculations were spot on. In an actual spin, the aircraft behaved exactly as the tests had predicted. After this, the XP80 was handed over to the Tactical Air Command. It was then flown to Chanute Field in Illinois. It became a real star there, mostly serving as a static display airframe. Only occasional specialized tests were run. In the fall of 1946, this legendary XP80 headed into a well-deserved retirement. It was handed over to the Smithsonian Institution for display. In 1978, the aircraft was meticulously restored. However, it remained in the workshops for a long time afterward, waiting for a proper exhibition space. Meanwhile, back in August 1943, military brass and Lockheed management met. They discussed the progress and future of the P-80 project. The military laid out some major new requirements. First, the second prototype had to have a pressurized cockpit. Second, and most importantly, they ordered the installation of the brand new General Electric UI-40 turbojet. This American design was considered far more promising than the British Goblin engine they had been using. The response was swift. By September of that year, before the first XP-80 had even taken to the skies, Lockheed engineers proposed the L-141 concept. This was a noticeably larger and heavier fighter. It was designed specifically around the powerful General Electric P-80 engine, which later became known as the J-33. The U.S. military loved the idea and immediately ordered 2 of these aircraft. They were given a new designation, the XP80A. The new engine boasted impressive performance, producing around 4,000 pounds of thrust. On top of that, the designers included a water injection system to give it an extra boost of power. The fighter's design also went through some major changes. The air intakes were moved further aft and now sat directly under the cockpit. The wingspan grew to 39 feet, wider than its predecessor. This was true even though the overall wing area decreased slightly to 238 square feet. The fighter itself got longer. It stretched from 33 feet to almost 34.5 feet, while its height reached just over 11 feet. Naturally, the aircraft gained some serious weight. Its empty weight topped 7,200 pounds, and its maximum takeoff weight jumped to nearly 13,800 pounds. Because of this, engineers had to significantly beef up the landing gear struts to handle the new loads. But the extra weight also meant more capability. The ammo capacity increased from 200 to 300 rounds per gun, and the internal fuel capacity went up from 285 to 485 gallons. This really extended its range. Unlike the first version, the new XP80A finally featured a pressurized cockpit. It also had modern air brakes and hydraulically boosted flight controls. This made it much more comfortable to fly. Detailed design work on the new model kicked off just 6 days before the baseline XP80 made its first flight. Incredibly, the blueprints were nearly finished just 10 days later. There were still a few technical details to iron out, like balancing issues and the need to redesign the wing. But the project was moving at a breakneck pace. in late January, a fateful decision was made. They would start building 2 L-141 prototypes alongside 8 pre-production aircraft. These were designated as the YP80. That meeting marked a major turning point for Lockheed's famous secret division, the Skunk Works. To get the fighter ready for mass production, management formed an elite core group of just 5 engineers. This approach would become the gold standard at Lockheed for the next decade. Here is how it worked. A small, highly efficient team of specialists would build a prototype. This completely bypassed corporate red tape. If the aircraft went into full-scale production, a separate group drawn from that exact same team would fine-tune the design right on the assembly line. The clock started ticking on January 24th. The engineers were given exactly 125 days to get the L-141 airborne. Just a week later, the project received its official designation, the XP80A. That same day brought another breakthrough. The I-40 engine reached 75% of its design power. It ran smoothly on the test stand for 5 solid hours. It was not without its challenges, though. The engineers ran into an issue with the exhaust nozzle overheating. This set the schedule back a bit. Several parts had to be redesigned on the fly. Despite this setback, half of all the blueprints were completed by March. Physical assembly of the fighter began in the middle of the month. The team worked around the clock. By June 3, 1944, the brand new airplane was practically finished. Painted in a sleek matte gray finish, it picked up the nickname the Gray Ghost. Ultimately, this incredible aircraft was delivered to Muroc Air Base 138 days after work officially began. This was a massive triumph for the entire team. The first XP80A jet fighter prototype took to the skies on June 10, 1944. At the controls was renowned American test pilot Tony Levier. The maiden flight lasted 35 minutes, but things got pretty tense toward the end. Due to technical issues, the fighter had to land with only one flap deployed. Levier also noted that the aircraft was highly unstable in flight. Just imagine the conditions inside the cockpit. The cooling system was malfunctioning so badly that it was blasting air heated up to 248 degrees Fahrenheit. The cockpit essentially turned into an oven. The engine itself also needed some serious fine-tuning. Because of this, the pilot was restricted to using maximum thrust only during the takeoff roll. But the biggest safety hazard was severe aileron flutter. This would kick in once the aircraft reached Mach 0.8. This was a direct result of compressibility effects. If the test pilot had tried to push the speed any higher, those vital control surfaces could have been torn completely off in midair. On August 1st, the second XP80A prototype joined the test program. It earned the unofficial nickname Silver Ghost. This aircraft differed from the first by featuring an extra seat meant for a flight test observer. Early in the testing, this aircraft also suffered from excessive heat inside the cockpit due to a flawed pressurization system. Engineers tackled that problem fairly easily. But soon a new, much more serious issue emerged. The airflow was unexpectedly separating inside the intake ducts. This created a deafening howl that rattled the nerves of both the crew in the air and observers on the ground. To solve this aerodynamic puzzle, Chief Designer Kelly Johnson personally took the observer's seat. As a brilliant aerodynamicist, he gathered the necessary data during the flight and came up with a clever fix. To prevent the turbulent boundary layer along the fuselage skin from entering the engine, they cut specialized bleed slots along the inner edges of the intakes. These vented the turbulent airflow outward, which completely solved the problem. This same second XP80A became the first aircraft in the Shooting Star series to test external drop tanks. They were mounted directly on the wingtips, holding about 165 gallons each. What is really fascinating is this. Contrary to the engineers' fears, installing these massive tanks actually reduced the aircraft's overall aerodynamic drag, the opposite of what anyone expected. Unfortunately, the life of the first XP80A prototype was short and tragic. On March 20th, 1945, its engine suffered a catastrophic uncontained failure in flight. The blast was so powerful that it completely severed the aircraft's tail section. Luckily, Tony Levier managed to bail out safely. To pinpoint the exact cause of this crash, investigators spent an entire year searching for fragments of the shattered turbine disc. Ultimately, The failed component was found a full 6 miles away from the aircraft's flight path. As for the second XP80A, it was later used extensively as a flying testbed for the brand new Westinghouse J-34 engine. This engine was being developed specifically for the upcoming XP90 fighter. Meanwhile, the project was moving forward steadily. In the spring of 1944, the military ordered a pre-production batch of 13 aircraft under the designation YP80A. Structurally and visually, these aircraft hardly differed from the earlier prototypes. They were fitted with powerful General Electric I-40 jet engines. These later received the designations J-33GE9 and J-33GE11. The main firepower was concentrated in the nose, with 650 caliber machine guns packed in tightly. The U.S. Army Air Forces saw this high-speed platform not just as a highly capable fighter, they also saw it as an ideal reconnaissance aircraft. So in the fall of 1944, the military ordered another airframe from the YP80A pre-production batch. But this time it was ordered as an unarmed recon variant. This variant was designated the XF-14. It is worth noting that before 1948, the letter F in the U.S. military designation system stood specifically for photographic reconnaissance. During the conversion, the machine guns were removed and a suite of reconnaissance cameras was installed in the nose. However, this recon variant's testing career was extremely short. In early December of that same year, the XF-14 was lost in a mid-air collision with another aircraft. Flight testing of the YP-80A pre-production batch began in September 1944. But it got off to a rough start. One of the first airframes crashed during its maiden flight in October. This fatal crash claimed the life of the renowned aviator and the program's chief test pilot, Milo Burcham. Despite this heavy loss, the testing program pushed forward. 4 other aircraft were deployed to Europe for operational testing under combat conditions. Commanders hoped to develop effective combat tactics for the P-80. They were particularly preparing for potential dogfights against the new German jets. The first 2 aircraft arrived in Europe in mid-December, but the deployment suffered a series of setbacks. One fighter crashed on just its second flight over England, killing the pilot. The other airframe was handed over to British engineers at Rolls-Royce. They modified it to test the experimental B-41 engine, the prototype for the legendary Rolls-Royce Nene. However, in November 1945, this aircraft was also destroyed in a crash following an engine failure. The other 2 examples were deployed to the Mediterranean theater. They flew a handful of combat sorties there, but never encountered enemy aircraft in the air. Both fighters survived their operational tour in Europe. However, their post-war fate was also unfortunate. Shortly after returning to the U.S. in the summer of 1945, one of the jets crashed. The second airframe survived a bit longer. It was eventually converted into a target drone for anti-aircraft training. The 9 remaining YP-80A fighters were used for a variety of tasks, including extensive military flight trials. The very first of these YP-80A jets was fitted with specialized flight test instrumentation. It was handed over to researchers at the NACA at Moffett Field in California. There, the aircraft was used to study the fighters' handling characteristics at high speeds during steep dives. 3 more aircraft, the 10th, 11th, and 12th YP-80A airframes, were sent to the 31st Fighter Squadron at Bakersfield Municipal Airport, also in California. There, they were rigorously tested by military pilots. On April 4, 1944, the military ordered the first major batch of production P-80A fighters. The plan was to build 1,000 aircraft split into 2 equal production blocks of 500 units each. Later, in June 1945, the Army Air Forces expanded their requirements. They placed an additional order for 2,500 P-80A fighters. However, with the end of World War II, the situation changed dramatically. That massive second contract was canceled completely. The initial order was also reduced, leaving just 917 aircraft on order. The first 345 jets from this reduced contract received the standard P-80A designation. Some of these aircraft were equipped with General Electric J-33GE11 turbojet engines. These engines produced 38 54 pounds of thrust. They were essentially the production version of the power plants previously used on the experimental XP80A and YP80A models. The rest of the airframes received Allison J33A9 engines. This was the exact same engine just built by the Allison division of General Motors. The next batch of 218 aircraft received an upgraded power plant, the Allison J33A17 engine, which delivered an impressive 4,004 pounds of thrust. This engine performed so well that shortly after, all the aircraft from the initial production run were retrofitted. They were equipped with these new, more reliable, and significantly more powerful engines. On January 19, 1945, North American Aviation signed a preliminary agreement to build another 1,000 P-80A fighters at their massive Dallas plant. The plan was for the aircraft assembled at this facility to receive a brand new designation, the P-80N. But history had other plans. With the war coming to an end, this massive contract was canceled. As a result, not a single P-80N ever took to the skies. The United States Army Air Forces officially accepted their first P-80A in February 1945. The last aircraft from this production run was delivered in December 1946. Interestingly, these early fighters were initially painted light gray. This was the natural color of a special aerodynamic putty. It was used to fill and smooth the joints on the skin of the aircraft to reduce drag. However, maintaining that finish in the field proved to be too difficult. Eventually, the USAAF abandoned the paint altogether, leaving the airplanes in bare metal. One production P-80A was converted into an unarmed photo reconnaissance aircraft. This was designated the XP80A. Originally, the military planned to give the reconnaissance version of the Shooting Star the F-14 designation, but that idea was eventually dropped. Externally, the new XP80A differed from earlier models with a noticeably longer nose section. This nose hinged upward. This gave mechanics quick and easy access to the large cameras housed inside. Another F-80A was modified in the field into a special reconnaissance variant designated the ER-F-80A. It received an entirely new suite of photographic equipment. This required modifications to the nose that gave it a unique profile. 38 standard P-80As underwent major modifications. They became dedicated reconnaissance aircraft under the FP80A designation. A bit later, the factory rolled out another large batch of these recon aircraft straight off the assembly line. All of these aircraft featured powerful nose-mounted cameras. They utilized the same hinged access as the early XFP80A prototype. Initially, they were powered by General Electric J33 GE11 turbojets. These produced 38 54 pounds of thrust. However, as technology advanced, the 98 reconnaissance aircraft still in service by 1953 were upgraded. They received newer Allison J33 A25 engines. These delivered around 5,400 pounds of thrust. This significantly improved the flight performance of the aircraft. Toward the end of their active service, many of these legendary F-80As found a new, albeit somewhat unusual role. They became target drones for pilot and air defense training. The manned targets flown by live pilots received the DF-80A designation. Meanwhile, the fully unmanned versions were designated as the QF-80A. In addition to their Air Force service, 3 P-80A aircraft were handed over to the United States Navy for extensive testing. They were signed Navy Bureau numbers, however, they were never given an official Navy designation or nickname. One of these airframes was specially equipped with an arresting hook and reinforced for catapult launches. This particular aircraft underwent rigorous trials right on the deck of the aircraft carrier USS Franklin D. Roosevelt. Despite the successful tests, the Navy never showed much interest in procuring a carrier-based version of the Shooting Star. The main drawback of early jets was their incredibly short range compared to standard piston engine fighters. To solve this issue, engineers came up with an unconventional idea. They suggested towing the jet fighters behind large bombers, just like unpowered gliders. The concept was simple. Upon nearing the target, the fighter pilots would start their engines and detach from the tow plane. To test this in practice, an F-80A underwent a series of test flights. It was towed on a cable behind a Boeing B-29A bomber. However, the concept proved far too complicated for actual combat conditions. The idea was quickly dropped. Meanwhile, other experiments continued. One P-80A was fitted with a completely redesigned nose featuring a flexible machine gun mount. What made it unique was that its 4 machine guns could elevate a full 90 degrees. It quickly became apparent that flying the aircraft and aiming the guns simultaneously was too much for one pilot. Therefore, designers added a second seat for a gunner. But just like the towing experiments, this complex setup proved totally impractical and was eventually scrapped. Another modified P-80A featured special wingtip mounts in place of the standard drop tanks. These were designed to carry 5-inch rockets. Engineers later took this a step further. They mounted additional rocket launchers right in the nose to maximize its firepower. They also armed another experimental P-80A with 4 20mm cannons. These were intended to replace the standard 650 caliber machine guns. However, this heavier armament never made it onto production shooting stars, so the idea was dropped. Designers continually looked for ways to upgrade the fighter. For instance, they mounted auxiliary Marquardt C-3010 B ramjets on the wingtips of one P-80A. Another aircraft received a similar setup using Marquardt C-2085D ramjets. Initial tests of these power plants took place on March 12, 1947. These engines were cutting edge for the time. By June 17, 1948, one of these experimental P-80As managed to make a brief flight. It was powered entirely by the thrust of its ramjets. The Shooting Star's military service officially began in 1944. At that time, military brass decided to send 4 pre-production YP-80A aircraft to Europe. Their main mission was to undergo real-world combat evaluation. They also needed to develop tactics to counter the latest German jet fighters. 2 of these jets were sent to Great Britain, but they met a pretty grim fate. One crashed. The second was modified to take a Rolls-Royce B-41 engine. However, it was completely destroyed in the fall of 1945. This happened during an emergency landing following an engine failure. The other 2 aircraft were deployed to the Mediterranean theater. They flew a handful of combat sorties, but never encountered any enemy aircraft. After the war ended, both of these fighters safely returned to the United States. In early 1945, several pre-production YP-80A fighters were delivered to squadrons. These units were based out of Bakersfield Municipal Airport in California. By February of that year, the Army Air Forces officially accepted their first production P-80A fighter into service. With the war in Europe winding down, these brand new jets began replacing older aircraft across American units in large numbers. They took the place of the famous piston-engine P-51D, as well as the early, somewhat underwhelming P-59A. By the summer of 1945, several more squadrons had been fully equipped with the P-80A. These combat groups were prepping for deployment to the Pacific Theater. Then, news broke that Japan had agreed to surrender. It is worth noting that during the early stages of introducing the P-80A, the accident rate was exceptionally high. On August 6, 1945, a major tragedy struck. Major Richard Bong, America's top flying ace of World War II, was killed in a crash while flying the aircraft. By that time, accidents had already resulted in the total loss of at least 8 aircraft. Another 7 were heavily damaged and 6 pilots were killed. The very next day after Bong's fatal crash, Army Air Forces Command issued a strict order. They grounded the entire Shooting Star fleet. This flight ban was briefly lifted in the fall before being reinstated. The main culprit was persistent issues with the J-33A9 turbojet engine. But even after flight operations fully resumed, the accident rate remained alarmingly high. By September 1946 alone, 61 of these aircraft had been lost or damaged in various mishaps. Interestingly, most of these crashes were not caused by airframe design flaws. The primary cause was pilot error. Aviators were transitioning to completely new and unfamiliar jet technology. Because of this high accident rate during the test phase, Army Air Forces leadership was eager to build some good press around their new fighter. So on January 26, 1946, 3 P-80As were prepped for a record-breaking flight. Their .50 caliber machine guns were removed to make room for extra fuel. The main goal of this mission was to set a new transcontinental speed record. They would fly from Long Beach, California, straight to LaGuardia Field in New York. Two of the pilots, Captains Martin Smith and John Beble, were flying fighters equipped with standard drop tanks holding 165 gallons. They managed to cross the continent in 4 hours 33 minutes and 4 hours 23 minutes, respectively. This time included a quick refueling stop in Kansas. But the standout performance of the day came from Colonel William Council. He posted the best time. He spent 4 hours and 13 minutes in the air with an average speed of nearly 577 miles per hour. The secret to his success was a set of oversized 310-gallon drop tanks. These allowed him to fly the entire distance non-stop. The record setting did not stop there. Just 3 months later, Colonel Council made a sprint in his P-80A from New York to Washington, D.C. He completed the trip in just over 20 minutes. Then, in June 1946, another American pilot, Lieutenant Henry Johnson, set a new closed-course speed record. He pushed his aircraft to an average of 424 miles per hour over a 621-mile route. The Shooting Star really made a name for itself during the first major post-war national air races. These were held in Cleveland in August 1946. There, these jets swept 3 major awards. The prestigious Bendix Trophy was won by Lieutenant Colonel Leon Gray. Piloting the FP80A reconnaissance variant, he made a high-speed dash from Van Nuys to Cleveland in just 4 hours and 8 minutes. Another major award, the Thompson Trophy, was claimed by Colonel Gustav Lundquist. He was flying a P-80A fighter flying a closed course of 112 miles. A special prize for the highest top speed of the event went to Lieutenant William Riley. He clocked an impressive 573 miles per hour. This success was no fluke. The very next year, in 1947, P-80A series aircraft returned. They swept both the Bendix and Thompson trophies all over again. To show off their newest jet fighter to the general public, the U.S. Army Air Forces organized a massive demonstration tour. In May 1946, 25 P-80A fighters flew in a spectacular formation over various cities across the United States. All of these aircraft belonged to a special fighter group. This group had previously handled the secret testing of America's very first jets. These were the P-59A and the P-80A itself. But despite putting on successful air shows and making a massive contribution to early jet aviation, this unit was officially disbanded in July of that same year. Throughout 1946, Shooting Stars began entering widespread service across multiple squadrons. They initially joined the ranks of several key fighter groups stateside. A little later, these modern jets were deployed to overseas bases. They stood alert alongside American forces stationed in Germany, as well as on the strategically vital island of Okinawa in the Pacific. To test the reliability of these new fighters in extreme conditions, a batch of 25 P-80B aircraft was sent up to remote Alaska in November of that year. There, they were put through a grueling 6-month cold weather evaluation in the brutal Arctic environment. There is also an interesting piece of trivia about their designations. In June 1948, the U.S. military changed its aircraft classification system. As a result, the base P-80A fighters and their FP-80A recon variants received new official designations. They became the F-80A and RF-80A, respectively. Later on, after the Korean War ended, military leadership decided to give these older airframes a second lease on life. Over 130 of the early F-80A fighters and RF-80A recon birds underwent a major modernization program. They were brought up to a much more modern standard, earning them the F-80C and RF-80C designations. Instead of being sent to the boneyard, these freshly overhauled jets were handed over to Air National Guard and Air Force Reserve units to continue their service. On top of that, the reconnaissance planes did not just get a simple refit. They were upgraded with much higher quality, more capable camera gear to tackle new mission profiles.